When building open source projects, it's important to be able to track usage metrics. While GitHub stars are rather vanity metrics, there are other ways to measure how people are using what you've built. Specifically, when building a Python library and pushing it to PyPI, it's actually possible to get a ton of information about how many downloads you are getting, but also which Python version, CPU architecture your user have, or even where the people downloading the Python library are located. In this video, we'll build this beautiful dashboard that helps you get insight about a given Python package. We'll be using DuckDB and MotherDuck for storing and processing the data, and a BI as a code tool called Evidence for the dashboard. We'll focus on the insight about DuckDB Python package, but the code will be flexible so you can get insight on any Python package you want. Every resources, including the full source code, is in the video's description. And this video is part of a series, and if you are just joining us here, well, welcome. We assume that you have already the data you need to start building, as we will only focusing on building the dashboard, so not ingesting and pre-processing the data. However, don't worry if you didn't do that first. The data will be there for you, ready to query. But let's understand the overall architecture and do a quickly recap of what happened in season 1 and 2.
A not so far long time ago, Mehdi covered an end-to-end data engineering project where in the first series, he covered the ingestion of raw PyPI data. This was using a Python pipeline and ingesting data to DuckDB to be able to write the results either to object storage like S3 or directly into MotherDuck. In the second video, we used dbt to define a simple model and transform our raw data into an actionable data set that would be used for our dashboard. The output of this dbt pipeline was in MotherDuck, but why? What on earth is MotherDuck?
All right, I'll take it from there. When building an analytical dashboard, you will have typically two prerequisites. First, the data, and second, a query engine, typically an OLAP database. Typically, the dashboard will often create behind-the-scenes queries, for instance, as soon as you change a filter to display the results, and these queries need to be performed somewhere, and they are typically analytical queries workload involving group by, sum, etc. So OLAP databases like BigQuery, Snowflake, or MotherDuck fit the best for these use cases. Business intelligence tools like Tableau, Power BI, and others all rely on an external query engine to fetch the data and then display it in the dashboard. Well, what about MotherDuck? Well, MotherDuck is a serverless analytics platform powered by DuckDB. It means that anywhere you can run DuckDB, you can run MotherDuck and leverage the power of the cloud. To build this dashboard, we created a share in MotherDuck that you can use directly. Share is a database that you can easily share, or rather attach from any DuckDB client. To access a share, you need to have a MotherDuck account. We have a free share that you can use, so go ahead and log in, and the share URL of the database. And once you are connected, you can attach a share with the following commands. Attach with the share URL. And of course, you can query the database shared from any other DuckDB client, would it be Python, Node.js, whatever programming language have you, there is always a Duck somewhere. Let's take a quick look at the DuckDB CLI, for example, how to connect to MotherDuck and read a share. The only extra thing I need here, assuming I have my MotherDuck account and my share URL, is the MotherDuck token to authenticate to MotherDuck. You can find this one in the MotherDuck UI. And I've put my MotherDuck token as an environment variable, so I can connect to MotherDuck using the attach_md command. As I already attached a share earlier in the UI, you can see I can directly see the share database and start querying. The BI as code tool we are going to use, Evidence, use the same mechanism to authenticate to MotherDuck. DuckDB in Node.js will connect to MotherDuck, and you may have guessed by now the only thing you'll need to configure in Evidence for MotherDuck is the MotherDuck token. Note that MotherDuck supports multiple other dashboarding tools, and I'll let you check the full list on our documentation website, link in the description. All right, let's build the dashboard. So first, let me give you a quick overview of Evidence. Evidence is an open source framework to build a dashboard using Markdown and SQL. At the end, you get a Node.js JavaScript application you can deploy anywhere or through Evidence Cloud. It's great because it helps you enforce software engineering best practice. Our dashboard will be versioned. We have clear view on the source queries, And we can deploy it to multiple environments if we want, mainly development, staging, production. To build a dashboard, you can start from a template provided by Evidence. And let's do a quick walkthrough about this one, and then we'll dive into the specific of our dashboard, which is getting insight on PyPI data for the DuckDB Python package. All right, so the first thing you want to do is basically git clone the Evidence MotherDuck template. So you can find the link in the description. And so I just have it already cloned, and then just open basically your favorite editor. I'll be using VS Code, and we're gonna open a new dev container, which is basically, as I mentioned earlier, a Node.js application. So we're gonna go forward and pick Node.js 20. And if you're not familiar with dev container, it's simply a VS Code feature to quickly create a container for your development environment. You pick from template. So now basically he's just building the container, and we'll reopen VS Code. So now I am in my dev container. I have Node.js dependencies, and we'll cover quickly the structure of Evidence project, which is including pages, source, and then there is Evidence plugin. And you recognize, if you're familiar with Node.js, the Node dependency with package.json. So let's start where the most important is, which is the pages. You can create multiple pages. We'll have only one pages for our dashboard. And here you have an index.md. So it's a Markdown file where you can write any Markdown that you would like. But you see you have specifically syntax to do some if-else condition, but also including some component. And again, if you've been playing with React or other framework, you see it's kind of like the same idea where you include a dashboard component. We'll go into that later, and basically write your SQL query that you're gonna use. So here you see that this is a SQL query daily service request querying from MotherDuck, which is the source connection. We're gonna see that. And basically the name here, daily service request, is used into .shard. You see, so it is shard here when I'm feeding this data, and I have on the x-axis create date. So initially I mentioned that the only thing you need to do is configure your MotherDuck token. And what we can do basically is just install the dependencies. So you just do an npm install, grab a coffee. Once you've installed the dependency, you can use npm run dev to start the local server. And as you can see, we don't have any graph display. It's normal. We didn't feed our service token. So coming back to MotherDuck UI, you can get your service token just by going to settings, and then here, copy your token, which is gonna be copied to your clipboard. And then in Evidence, you just go to the setting page, and you see you have a data source here. You click edit, and here you have the value of the token that you're gonna pass. You can test the connection. And again, to make a relationship with what we discussed earlier, we have basically a DuckDB client in JavaScript running on Evidence framework. And this is basically leveraging the MotherDuck extension and just connecting to MotherDuck with the token, which is required to authenticate. So the connection is successful. Don't forget to confirm the change and save it. And now if you see, you have MotherDuck queue to update, and it's managed to fetch the data. So if we go back to home now, we see that we have the data which is displayed, and we can also play with the filters, the slider here, and have some more information here about the New York City service request. All right, coming back to our repository. So we talked about the main spaces where we define SQL query and components, which are our graph or charts, if you prefer. You can head down to Evidence's documentation to see all the charts that they have. Basically, here you see you have an area map. And you see it's just a component. You feed the data based on a SQL query that you define in Markdown, and you have your charts. So it's really a quick way to iterates, because when you have your server running locally, which we do, right? You can basically adapt any query, any graph, and see the result of your dashboard directly. So the other thing I want to cover is the source. And as you see in the source folder, we have MotherDuck, which stands for the MotherDuck source. We have the connection option, and this is generated. This is where our MotherDuck token is stored. You should not get this one, by the way. So this is just a configuration file to save the token locally. And when we're gonna deploy to the cloud, any other service, you will store them as an environment variable. Then you have the connection.yaml, which just specified the type of the connection for evidence, which is MotherDuck. Then you have the source query, and the source query is really your data, your source query in MotherDuck. And you see that we are querying the simple data, New York City and service request. This is named New York City service request volume. And if you go back to our graph, we're gonna see that if we look at the from statement, we have from MotherDuck, which is, the source here folder, and then the name of the query, which is the name of my SQL file, okay? So you define the source query here, and then you can leverage this table based on the name, which corresponding to the SQL file name. By the way, I can also run those query basically in MotherDuck if I want, right? So if I run this query, I'm gonna have the result here, which is the one which is feeding the dashboard. Simple database is basically a database which is attached by default for any MotherDuck user and contain a series of sample of data to play with. That's why we didn't have to do any attach commands. But for the specific database that we are going to use for PyPI data, it's a dedicated database, and I'll provide the share URL so that you can attach on your side. But that's why we had to attach earlier to be able to query this database. The last one I want to cover is the evidence plugins. You see that you need to have some plugins defined depending on the source that you are querying. Here it's MotherDuck. It's included in the template. And that will download specifically some package for you dependency required. But that's it, that's pretty much everything. So in Pages, you define your SQL and Markdown, and I'll using irreducible component to define charts that you can find in evidence documentation. We have the connection, which is specifying the type of the source, and we define the token through the UI, and it created connection.option.yaml, which contain the token locally. And then we have a source query, which is basically going to be referred in my Markdown file. All right, so let's build our own dashboard now using the DuckDB PyPI stats data. And for that, we're going to define a source query. And then in our Markdown file, we'll play around 3 kind of charts. So diving now on the main repository, as a reminder, it's a monorepo setup. So we have the ingestion pipeline, the transformation pipeline, and the dashboard into the same repository, which is PyPI Duckflow, again, link in the description. And we created a dashboard folder, which basically is the structure that we saw just earlier with basically the MotherDuck template from evidence. And if you open this project, you can also reopen in dev container. And the beauty of it is that we see that we have 2 dev container definition. We have one for the ingestion and transformation, which is Python. You see, that's what I'm proposing when I'm reopening container. And the other, which is Node.js for the dashboard. So I'm going to click that one. To going into the dashboards folder, which is where the evidence dashboard is, you can run, again, the same local server, add your token so that you're ready to connect to MotherDuck. And don't forget to do the attach command to the share database DuckDB stats so that you can access this share database. You only have to do it once, so you can do it using the MotherDuck UI as we did before, or the DuckDB CLI. The first thing we want to do is basically write the source query. And so to define this source query, we can have a look at the source data. The raw data set basically here is PyPI file downloads. One row represents one download, so this is really granular. In details, there is a lot of information regarding CPU, architecture, and so on. You see that we computed in PyPI daily stats, and we group by a series of information. We have the country code and the Python version. So this reduced already drastically our data set. So the raw data set contains more than 44 million. So yes, that means that DuckDB has been downloaded more than 44 million over time since its release in 2019, at least the Python package. And if you look at PyPI daily stats, we have about 1.7 million rows for when it's aggregates per day. And so these thoughts of like how much aggregation you need is really important, because you want basically to optimize your dashboard to fetch as less as possible data, right? So if you don't need that much granularity or a specific daily view, or maybe you just need a daily view for the last 7 days, you may want to create a dedicated source query or a dedicated table to basically speed up your dashboard and avoid pumping too much data to the client. So coming back to a source query, I want to define basically a weekly download view based on the daily download table view that I have. I'm also filtering just a couple of columns that I'm interested to, which is the DuckDB version, country code, Python version, doing a sum to have a weekly download sum. And I'm basically getting the week start date based on the download date. So this gives me the date of the Monday for every other week. So if the download date is happening on Friday, it will refer to the Monday date of that week. And then I can do group by and have a weekly view. But I can also see basically the growth over months and over year easily with that. So yeah, again, feel free to use the UI to basically prototype your query. You see here that I still have like 300,000 rows, but it's still much less than the 1.7 million rows. Okay, so what I'm gonna start is just getting a view on last week's download. We're gonna do a line chart of view over time, and we're gonna do a bar chart of the Python version that people use. So for the downloads of last week, I can just use this, which is a big value. You see there is a couple of things that I can even add to compare versus last week or last month. I'm just gonna keep a big number here to keep things simple. So first thing I want to show you is that you can chain a SQL query. So here, for example, what I'm computing is the last 4 weeks of the current day when this is running, so that I have a list of a view of the past 30 days, but also easily can filter on the last week. So whenever I save basically this and I have my local server running, I can inspect actually the result of this query and if everything is going well in the evidence dashboard. And by the way, if you don't see those query results and the query definition, you just go to setting and you can see maybe it's hide. So if I hide them, they're hidden by default. So when you see the final dashboard, you don't see actually the queries. So now that I have a result giving me the 4 last week, we can start with a line chart to see the weekly download. And as you can see here, I'm chaining actually the result from the last weeks, taking everything except the last week, which might be the current week and not incomplete. Because otherwise, as we saw, the downloads are growing and you're always gonna have a drop as the week is, getting complete. So now we have the results here. Again, I have my query results. So we can just pick a line chart. So going to the documentation, we have line chart. This is how I define it. So here I'm defining my line chart, and you see I specifying the query here and with the weekly downloads and the weekly start, which are the 2 column Y and I and X axis. And that's it. We have my graph, which is download per week. All right, let's do another one. Let's do the big value one and the bar chart. So here is my query to get the download by last week. Again, I'm filtering by an offset to take a full previous week. So my graph is basically another component. You see I'm referring the data, which is this query, specifying the value, and here is the formatting. And yes, it's a big value for DuckDB. We have to count in millions for weekly downloads now. If you have a small project, maybe you want to fine tune the format. And that's it. We see that the last week was 1.10 millions. And that's exactly what we can find. It is rounding up. It's 1.0.95 actually. But that's correct. You start to get the grip. Let's do one more bar chart to display the number of downloads per DuckDB version. And so here I'm actually looking on the past 4 weeks, because DuckDB is evolving, and it's the same if you want to look at Python version. I don't think it makes much sense to look at the full time period I think the last 30 days give you a good insight who has been upgrading their DuckDB client or not. And let's go again to the documentation and look for a bar chart like this. I like horizontal bar chart. So I added the bar chart specifying the query, DuckDB version, total download, and I'm swapping to get an horizontal one. And yeah, it's working. So you see that on the past 30 days, we had mostly 1.0, which was download, which was a big event. And then the rest, we still have a lot of client on 0.10.3, 0.10.2. All right, one more thing I want to cover is the layout. You can custom a bit your layout, colors, everything. And you see that for me, I had a simple logo. I set to not show the queries by default. I had the sidebar. The sidebar is when you have multiple pages. So you can have a look also and fine tune the design of your dashboard. All right, once you're done, you can basically deploy it to Vercel or Netlify as it's just a JavaScript application. And Evidence has their own cloud to make you easy to publish. And the only thing you need to specify when publishing is your environment variable for the MotherDuck token. There's multiple other things we haven't covered in Evidence. You can add, of course, filters to dynamically change your queries and your dashboards, but at least you get a grasp on how things are working together. All right, that's it for this video and for the series of this end-to-end data engineering project. In this last part, we built the dashboard using a BI as code tool called Evidence and leveraging MotherDuck as our central data repository. Note that the series might be finished, but we could all cover plenty other things, how to orchestrate the pipelines, how to do data observability and data quality. So let me know what you would like to see in these comments. And in the meantime, keep coding and keep quacking.